Welcome to this presentation on Shielded Metal Arc Welding, or SMAW electrodes. In the next few slides, we'll explore how electrodes work, their structure, classifications, and why they are vital to producing strong, reliable welds. Let's dive in. Oxygen is not our friend. Metals at high temperatures are highly reactive with the oxygen and nitrogen in the air. When molten weld metal comes into contact with air, undesirable porosity, oxides, and nitrides form. These defects reduce the strength properties of the solidified weld joint, leading to compromised structural integrity. That's why shielding the weld pool from air is critical in shielded metal arc welding. Where does weld metal come from? This slide introduces the origins of weld metal. We can see various examples here: a spool of gas metal arc welding wire, flux cord arc welding wire, shielded metal arc welding electrodes, and gas tungsten arc welding filler rods. For this presentation, our focus is on shielded metal arc welding electrodes, outlined here, which are central to SMAW processes. SMAW, electrodes, structure. Where does weld metal really come from in SMAW? The key lies in the electrode. This diagram shows the electrode structure, consisting of a steel core surrounded by a flux coating. The steel core supplies the filler metal, while the flux protects the molten pool by shielding it from atmospheric contamination. These electrodes are essential for creating strong, defect-free welds. Filler metal specifications. Understanding the filler metal specifications is essential for choosing the right electrode. AWS A5.1 outlines specifications for carbon steel electrodes. AWS A5.5 covers low alloy steel electrodes for demanding applications. AWS A5.4 focuses on chromium and chromium nickel steels for corrosion-resistant welding. These classifications ensure the electrode matches the application, metal type, and environment. Electrode classification system. Let's break down an example of an electrode classification, E7024. The E stands for electrode. The 70 indicates a tensile strength of 70,000 psi. The 2 signifies it's suitable for welding in flat grooves and horizontal fillets. The 4 indicates it has an iron powder titania coating. This system provides critical information about the electrode's capabilities and application. Understanding E6010. The classification E610 reveals vital properties. The E means electrode. 60 shows 60,000 psi tensile strength. The 1 indicates it can be used in all welding positions. The 0 identifies a cellulose sodium flux, which offers deep penetration and is used with DC reverse current. These numbers allow welders to select the right electrode for the job. Common tensile strengths. For SMAW electrodes, the first 2 digits typically represent tensile strength values in thousands of psi. Common strengths include 60, 70, 80, 90, 100, and 110, depending on the application's structural demands. Welding positions. This chart outlines electrode compatibility with various welding positions. 1 electrodes can be used in all positions: flat, horizontal, vertical, and overhead. 2 electrodes are limited to flat and horizontal positions. 3 is for flat welding only. 4 electrodes can handle flat, horizontal, vertical down, and overhead positions. These capabilities are key for planning welds in complex projects. Common SMAW electrode coatings. This table lists common SMAW electrode coatings and their properties. Let's focus on 2 highlighted coatings. XX10, high cellulose sodium, offers deep penetration with DC polarity, ideal for pipe welding and positions requiring high adaptability. XX18, low hydrogen with iron powder additions, provides excellent toughness, crack resistance, and ductility with AC or DC polarity. It's commonly used for structural steel and critical applications. Choosing the right coating ensures optimal performance and weld quality. Electrode sizes. Electrode size refers to the diameter of the steel core, not the flux coating. This distinction is important because the core diameter affects the weld bead size and current settings. Selecting the appropriate electrode size ensures precise, strong, and efficient welds for any application. Thank you for joining this overview of SMAW electrodes. Understanding these basics ensures better welding practices, improved safety, and stronger results. If you have any questions, now is the perfect time to ask.